Find a polar equation that has the same graph as the equation 2y equals the opposite of x. Well, if 2y equals the opposite of x, and we know that y equals r times the sine of theta, and that x equals r times the cosine of theta, then we can make those substitutions and write 2y equals the opposite of x as 2 times r sine of theta equals the opposite of r times the cosine of theta. And then we can rearrange that by first noticing that we can divide both sides by r. We can also divide both sides by the cosine of theta to obtain 2 times sine over cosine, which is tangent of theta, equals negative 1, or tangent of theta equals negative 1/2. So if the tangent of theta equals negative 1/2, there is a specific angle in the first quadrant in particular, which has, in the second quadrant, which has a tangent value equal to negative 1/2. We could solve, if we liked, to write this as the inverse tangent of negative 1/2, and that'll, because we're writing this with an inverse tangent, we'll get an angle between minus pi over 2 and pi over 2 as a result. That's going to be a constant angle, and the graph of a polar equation with a constant angle and no mention of the radius r is the graph of a straight line, because the angle gives a direction, and the radius being unrestricted means we can use any radius or r value that we like. And so as this equation is the equation of the line y equal negative 1/2 x by just dividing both sides by 2, this equation gives us the same graph and will just be a straight line in the plane.